Hi, I'm Ms Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. Okay, so now let's look at this one. But as we differentiate this is going to involve implicit differentiation. And if we leave it in the form that we have it now, the natural log of x times y equals e to the x plus y, the x times y inside of the natural log is going to involve, first of all, a chain rule. And second of all, in the process of doing that chain rule, a product rule. So you can see where that would be really, it's doable, you can do it. But what could we do with the expression natural log of xy according to the rules of logs that would help to simplify that a lot? Okay, so here's the rules of logs. Okay, which one of these rules might be helpful on the left side of this relation? Product rule is correct. So according to the product rule, you can break it up. Instead of it being a product inside of one log, it can be the sum of two separate logs. So we're going to break this apart. Natural log of x plus natural log of y equals e to the x plus y, using the product rule on the left side of the equation. Again, this is called expanding the log, and it is not calculus, it's algebra. We're using some algebra to rewrite it because it's going to be much simpler to take the derivative now. We're trying to find dy dx, and we have to do it implicitly because we can't solve for y in this equation. So we're going to differentiate on both sides with respect to x. So we have the derivative with respect to x of natural log of x plus natural log of y equals the derivative with respect to x of e to the x plus y. Okay? In order to perform this differentiation, we are going to need to remember a couple of rules, right? We're going to need to remember the derivative of the natural log of x is 1 over x. And we're going to need to remember the derivative of e to the x is e to the x. And we're going to have to remember when it's appropriate to use the chain rule. Let's go for it. So we're going to take the derivative of each term. I'm going to write an extra step just to make it clear, hopefully, what I'm doing. So the derivative of the natural log of x plus the derivative of the natural y equals the derivative of e to the x plus y. All right, what's the derivative of the natural log of x? Good, 1 over x. Plus, what's the derivative of the natural log of y? That's supposed to be a y there. What's the derivative of the natural log of y? It's 1 over y, but since the variable here doesn't match the variable here, what do I have to put next to the 1 over y? Good, dy dx, which essentially is a chain rule that's happening there. All right, and then on the right, we have e to the power, all of that is in the power, x plus y. So this is a composition of functions. One function, x plus y, is plugged into the function e to the x. So we're going to use the rule for the derivative of e to the x. It's going to just stay e to the x plus y. But to compensate for the fact that that wasn't just an x, we then have to differentiate the inner function, which I'll do in the next step. So we have 1 over x plus 1 over y dy dx equals e to the x plus y. All of this I've just copied. Nothing has changed. And then now let's focus on the derivative of x plus y. What's the derivative of x with respect to x? 1, good. Plus, what's the derivative of y? dy dx, good. Okay, we are so close. We're trying to find dy dx. We have differentiated. Now we just need to get dy dx by itself, so we have some algebra to do. But notice that the dy dx on the right side of the equation is stuck in the parentheses with the 1. So we're going to have to distribute to get it out of those parentheses. So we have 1 over x plus 1 over y dy dx equals, distributing here, we're going to have e to the x plus y plus e to the x plus y dy dx. Now, whenever the dy dx appears in more than one term, we get the terms that contain it to one side and everything else to the other. I like to bring it over to the left usually. So I'm going to have 1 over y dy dx minus e to the x plus y dy dx equals e to the x plus y minus 1 over x. And then, of course, we factor out the dy dx. So we're going to have dy dx times 1 over y minus e to the x plus y is equal to e to the x plus y minus 1 over x. And now we divide. So we're going to have dy dx equals e to the x plus y minus 1 over x over 1 over y minus e to the x plus y. Okay, it's essentially the same steps in all the problems at this point here, starting here, getting the dy dx to one side, factoring it out, and dividing. So it's gonna look complicated, but if you really kind of clear away all the mess, the procedure is the same. Now we're going to usually not want to leave a complex fraction. So I like to look at the little denominators within my fractions and multiply on the top and the bottom by the least common denominator. So I'm going to distribute that to each part and that to each part. So we're going to have dy dx equals xy e to the x plus y minus y over x minus xy e to the x plus y. And that is the final answer. Okay, so a good study tip for as we're getting into these longer problems is to look at the examples that I give you in the notes or the examples in the textbook or both and read through it carefully. Make sure you understand where each step came from, but then cover up the work and see if you can rewrite the whole problem on your own. You're not going to be able to memorize steps in calculus. You're going to have to look at each step and you're going to have to determine what needs to be done. And so one of the ways to practice that is with problems that you already have worked out. See if you can work them out again without looking. You can do the same thing in your homework, especially if you're using the MyLabs, because in MyLabs it has a show me an example. And a lot of times we can imitate the example when we have that example pulled up, but can you actually work out all the steps when you put it away is the question. So keep that in mind. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.